But I'm going to make you do some of the circuits. Just see if you are ready. Okay, we've done all the basics. We've done this example. Okay, there we go. I want you to quickly draw that electrical circuit there. So we have a battery with a 6-volt potential difference. Then there's an ammeter in that circuit. It's not number 3. That reading on that ammeter is 3 ampere. And then we have an ammeter here with a reading of 1 amp, 1 ampere. And that, let's make it orange. This ammeter here, we don't have a reading. That's ammeter number 1. And then there's also a voltmeter here. Voltmeter 1. So those orange things, the orange ones we don't have the readings for, but all the green ones will have a reading. So like everything that we have a reading, I'm going to make green, and everything that we don't have a reading is orange. So we need to use those basic concepts that I've taught you to determine the values. Okay, it's in Afrikaans now, but I'll translate it to you. So the first thing I want to know in 2.1 is, what is the total resistance? Remember, you're going to use the equation V equals I times R as your standard equation. Go. Make a drawing, and then I want the answer. The total resistance. The resistance of the whole current. Of the whole circuit. So I just want to show who's in the class at the moment. It's Saskia, Calvin, and Zalnay. Who's missing?
Akifa, but she is absent today because it is their Eid.
Eid. Okay, quickly, you have 1 minute left. Answer, please, Zelnay.
So just give me a second. I am just busy. So I just need 2 minutes.
Calvin.
So is it?
Come. What is R?
R is resistance.
V over I. So if
V
I have
over
the
I.
total potential difference and I can divide it with the total current, then I get the total resistance. So if I want the total resistance, I need the total potential difference and the total current. Tell me if I've got those things.
We have the total current.
Okay, the total resistance is the total potential difference divided by the total current. What is the total potential difference? It's the reading over the battery, isn't it? Because that's the total potential that can be lost. That is 6. And the total current is the current that flows through this part of the circuit. So that's 3. So the resistance is 2 ohms. That's the total resistance. Come, that was quite easy. Too easy. Good. Then I want the reading on A1. In other words, what's the reading there on A1? There's two ways of doing it. Two ways of doing it. 2.3. What is the reading on A1? I wouldn't say that you've done a lot of examples, because otherwise someone would just give me the answer quickly. Sorry, that's not A1. This is A1. Help me. Yeah, answer please.
Okay, I'm going to try. Will it be V equals IR?
That's one way of doing it. Okay, but look at this. There is a total of 3 amps running through this circuit. Then some of it goes through this part of the circuit, and some of it goes through this part of the circuit. It's like a water pipe that's split up into 2 sections. Now, if I have 1 amp here, then only 2 amps remain there. You see that?
Yes, sir.
So I started with 3 amps and it's split up into 2 lanes. So basically it happened like this. You had 300 Rand here. And it's split up into 2 sections. You bought 2 things. The one thing was 100 Rand. What was the other thing that you bought? 200 Rand. It's exactly what happened there. We had 3 amps. And it's split into 2 parts of the circuit. So we started off with 3 amps. And the one section is 1 amp. So this section must be 2 amps. So I can just do this. The total amps is ammeter 1 plus 1 ampere. Therefore, 3 equals A1 plus 1. A1 is 2 amps. That's one way to do it. The other way to do it, I'm just going to take some of this color out because it can be really irritating. The other way is to reason as follows. The current is the potential difference divided by the resistance. So do I know the reading, the voltmeter reading there and the resistance? No, I don't. I actually don't. So if I had the resistance there, I could have calculated the voltmeter reading there and the current, or I can get the voltmeter reading. So that's a long method now because you have to work out a couple of other things. So we're going to not do that. We're going to do 2.4 first. No, 2.2. We skipped 2.2, didn't we?
Yes, we did.
Okay, wow, you didn't tell me that. Because that would have helped a lot. So let's do 2.2 and then come back to the second method of 2.3. Help me with the voltmeter reading on V1. That blue one. What's V1? Come, that's a basic principle. There's no extra resistance in the circuit. There's only 2 parallel resistors. So that voltmeter there and that one must be the same. So that's 6 volts.
Shell, why will V1 and 6 volts be the same?
Look, there's various ways to think of it, but let's do it the following way. Okay, there's a circuit now, and let's say it's 6 volts, the potential difference over the battery. Now I've got 2 resistors in parallel here. Let's assume there's 2 resistors in parallel here, and there's the circuit. Now, if I put a voltmeter over one of them, I can reduce those 2 resistors into 1 resistor. The voltmeter will stay intact. There's the new resistor. The voltmeter will stay intact. That voltmeter reads the potential difference that's lost over that resistor. And I only have 6 volts to lose. That's the total potential difference. So all the 6 volts will be lost there. So I made you learn the following. Very important. So if I have a battery and I have a voltmeter there, It doesn't matter how many resistors are put in parallel. Doesn't matter. They will all have the same voltmeter reading, and that's the voltmeter reading over the battery. So V1 equals V2 equals V3. Doesn't matter. If we have an additional resistor in the circuit board, then it changes. The electrical circuits, you will have to go in practice. You're not good enough. Exam is around the corner. Okay, let's do 2.4. What is the reading on R1? Okay, so there's R1. What I have that voltmeter now, 6 volts. And I have the reading on the ammeter at the bottom. That was what? 2 amps. Okay, so calculate the resistance of R1. R equals V divided by I. The potential difference lost there is 6. The current is 2. And the resistance is therefore 3 ohm. Very important. I'm not allowed to say this, but at the moment, you 3 suck. Huh?
Okay. Practice.
It's very important that you understand that. 2.5. R2. I want to know what's the resistance in R2. Everyone, take a minute and get that answer for me. If you have to, put your own voltmeter over R2. Then I want the answer. There's 2 ways of doing it. I'll show you both. But the easiest way is to put your own voltmeter over. I showed you last time to put your own ghost voltmeter. So you put a voltmeter there, you call it VR2. Put your own voltmeter there, give me that reading, and you have the amps. So it's very easy. Okay, anyone's got an answer?
Not yet. No.
What is the voltmeter reading? What is the volt VR2? What's that reading over that voltmeter?
Volt.
6 volts. Remember, the voltmeter reading over both of these resistors will be the same, irrelevant of what their values are. So that potential difference over that resistor is 6 volts. So now I can get the resistance because it's the potential difference divided by the amps. The resistance is 6 divided by 1, and that resistor is 6 ohms. Quickly dot that down. Okay, can we continue?
Yes, sir.
There was another way.
So I just want to make sure
Yes, I'm listening.
the VR2 equals 6 6 volts. Is that just to tell us that both those resistors will have the same volt amount?
They both
equals to
will have the
60.
same potential difference. I'll go through it in a minute again. Okay.
Okay. Thank you.
Okay, this is the other method. This is method 2. 1 over R parallel is 1 over R1 plus 1 over R2. That's a way to calculate the resistance in a parallel circuit. So 1 over 2, because the resistance was 2 ohm, we calculated that, is 1 over R1. R1 we did. R1 was what? 3 ohms. So it was 1 over 3 plus 1 over R2. Then I just calculate this. So it's half to minus a third is 1 over R2. Go to your calculator and do a half minus a third. Okay. Then you get 1 over 6 is 1 over R2. Then you just flip that around. Therefore, R2 is 6 ohm. It's another way of doing it. Method 1 or method 2.
Okay.
Write that down, please.
Okay, all good.
Okay. This is very important. Let's just look at this basics again. So if I have a battery there, and the potential difference is 12 volts. Now, look at this. I have a resistor here, which is 2 ohm. And I have a resistor here that is 4 ohm. And no other resistor. There's nothing else. Then the potential difference over this 4 ohm will be 12 volts. And the potential difference over the 2 ohm will also be 12 volts. That is super important. Okay. Now, if we add another resistor in the circuit, let's assume that it's here somewhere. I'll color that one in. And we add 4 volts there. That means of the 12 volts, we've lost 4. So the potential difference to lose over the parallel circuit is only 8 volts then. That is very important. That's what's going to make and break this chapter for you. Did you get those 2 pictures now?
Almost done.
Write that one down. You must have both. Quickly write this one down. I'll go back and I'll redraw the other one. Okay, let's draw the other one again. Can I?
Yes, yes, we're done. Thank you, Sean.
Done.
That's the other picture. That's very important. Tell me when you finish with that one, then you're going to do another example. I hope you've done all the examples. You haven't done the examples in your textbook. I know that. Otherwise, you would have done the work today without any hiccups. You are not going to pass if you don't practice.
Okay, sure. So where can we find past papers? On Impact Opni portal, I've tried, but it keeps telling me, it keeps giving me the plagiarism
No. You
videos.
just go on the internet and type in grade 10 physical science papers, and you'll get Eastern Cape papers, you'll get normal caps papers. There's hundreds of them online.
Okay. Okay. Thank
Right. Okay. Then this is a new circuit board. The reading on voltmeter 1 is 15 volts. Quickly draw that. Happy? Got it?
Almost. Almost.
Okay. Just a rough drawing. Okay, good. First thing I want to know is, what is the total resistance? If they don't ask you this, it's always great to figure that one. If you get that, if you can get the total resistance, then half the battery is normally 1. What is the total resistance of the circuit board? Okay, would you agree with me that the total resistance is the resistance in series plus the resistance in parallel? Now look at this, very important. If I put a voltmeter here, this is not going to be 15 volts. Do you agree?
Yes.
Because some of the potential difference is lost through V2. So if I have the reading on V2, then I have the potential difference over those parallel again. But anyway, that's not the question. So would you agree that the total resistance is 2,67? This is this one in series, plus whatever we get out of the parallel circuit.
Yes.
The parallel circuit, you can calculate 1 over R parallel is 1 over 6 plus 1 over 4 plus 1 over 3. All right, quickly, everyone calculate that. So I get a 3/4. And if I flip it around, I get 4 over 3, which is what? 1,33. Oh, that is the parallel section. Therefore, the total resistance is 2,67 plus 1,33, which is 4. That is a very important reading. Please write that down. Tell me when you're finished.
But then,
I'm also done, so
Okay. Right. Next question is, I want to know what is A1. So let's make this the second question. What is the reading on A1? In other words, this ammeter here. That you must be able to do in 15 seconds. You must write the formula, you must write the values and get the answer in the right unit. Quickly, everyone do it. Right, answer please. The current is the potential difference divided by the resistance. Okay. All the current goes through there, all the current. So I wanted the total potential difference divided by the total resistance, which I just got, which is 4. What's 15 divided by 4?
15 divided by 4.
3,75 amps. You must write the equation, you must put the values in, you must have the answer with the right unit.
Okay.
Otherwise you lose marks. Number 3. I want to know what is the reading on voltmeter 2. Done. Help me out, someone. Equation.
Well, the equation V equals IR.
Yeah. Current going through that resistor.
Current going through that resistor, would it still be 15 volts or would it break down?
No, current.
Current. Oh dear. Now I've lost myself.
The total current flows through every part of the circuit board that's green now. It's like one pipe. If there's only one pipe, then all the current must flow. Current's like water. All the water must flow through that green section. It only splits up in the blue section.
Okay.
But in the green section, all the current flows.
Including by voltmeter 2,
Pardon?
would it be, would the current also flow through the voltmeter 2 section?
No, the voltmeter current doesn't flow through a voltmeter. The voltmeter reads the potential difference between these two parts of the circuit board, between A and B or P and Q. It reads the difference in potential lost between those two parts of the circuit board. So, but that won't be 15, eh?
Okay.
Why not? Because there's also potential lost in that blue parallel circuit. So it must be less than 15, obviously. The current flowing through that resistor is 3,75 and the resistor is 2,67. And that is what? 10 volts. So voltmeter 2 is 10 volts. So Saskia, what do you know now? That's very important. All the potential difference. This V reading is 5 volts. Do you agree? This one is 5 volts. This one is 5 volts. Why? I've lost 10 volts now out of the 15. So only 5 remains, and everywhere in the parallel circuit part, it's the same. So now the last question. What is ammeter 2 reading? Go on your own. Okay. The potential, the current there is the potential difference there divided by the resistance there. The potential difference there is 5 volts. The resistance there is 6. 5 divided by 6. And that is 0.83 amps. Therefore, A2 has a 0.83 ampere reading. You finished?
Yes, sir.
Okay, same type of thing. Good. The potential difference over the battery is 20 volts. Right, there's an ammeter 1. Okay, let's just make sure that we all know the following. Everywhere that I make a green section now is where all the current is flowing. Is that correct?
Yes. Yes.
Then in that parallel section is where the current is actually split into 3 parts.
Yes.
Quickly draw that and calculate the total resistance for me. What is RT? If they don't ask you that and you can calculate that, then you've got a lot. Oh, you can't calculate the total resistance. We can't. We don't have that resistor, nor do we have the ammeter reading. Oh, this is quite interesting. This is a nice circuit, a harder one. Okay, so the first thing I want to know is, no, we can't. The first thing then I want to rather know, we can't do that yet. So the first question is, what is the reading on A1? What is that reading there? And then I want you to calculate the total resistance. Make a drawing, calculate A1. Okay, are you finished with that drawing?
Yes. Sure, I'm just a little lost. How do we know our resistance?
How do we know?
Our resistance. Or do we
Where?
work out our resistance first?
Oh, the total resistance. That one you can't do now.
Oh, okay. So then we'll probably have to work out the resistance before we...
Look at this. Do you agree that all the current flows through that section there that I made pink now?
Yes.
Okay. Where else does all the current flow through?
On your left-hand side?
Yeah, there. And yeah. But if I can get all the current here, through this section here, if I can get all the current there, then I have all the current. Okay. So can I get all the current there? Yes. I equals V divided by R. The current there is the potential difference there, which was 10 volts, over the resistance there, which is 5. The current is 2 ampere. So the current there is 2 amps, but that's the total current. Because the total current flows through there. Therefore, the reading on A1 is 2 amps. Is that correct? Yes.
But sure, why do we use the 10 volts and not the 20 volts? Is it because it
Because the potential
broke up?
difference there, the potential difference lost there is not 20. And we couldn't use the 20 because we didn't have the total resistance. We only had the resistance there in that section.
Okay.
I could have calculated the total current if I had the total volts divided by the total resistance. I have the 20 volts, that's total, but I don't have the total resistance because of this resistor here, I don't have.
Okay.
So now at least I know that everywhere where the circuit is green, there is 2 amps.
Okay.
Good. I want you to calculate A2 now. What is the reading in A2? Tell me if you are struggling. I will put my own voltmeter there. Call it the voltmeter reading over the 3 ohm resistor.
Will we use the same formula again?
Yeah, there's only one.
Okay.
I is V over R. I'll tell the teacher, I'll just tell the teacher the following. The voltmeter reading over the 3 ohm resistor is what? Is 20 minus 10. Is that correct? Because I have 20 and I've lost. Oh, I can't do that. Sorry. I missed out something. I can't do that. Damn. I still need the resistor here. I don't have that resistance. Okay, so A2 was a difficult question. I cannot do A2 until I find R. So let's just do R first. What is the total resistance? Let's just do this in steps, baby steps. What is the total resistance? The total resistance is the total volts divided by the total amps. Do we have the total volts? 20 years. Do we have the total current? Yes. I, that's 2. We just calculated that. So the total resistance is 10 ohm. Now we can get R. But let's just do a step in between. I want to know what is the resistance of the parallel part. What is the resistance of the parallel resistors? You can do that one on your own quickly. I'll give you a formula. 1 over R parallel is 1 over R1 plus 1 over R2 plus 1 over R3.
So my answer is 1.
Okay, let's see. 1 over R parallel is 1 over 3 plus 1 over 2 plus 1 over 6. Is that correct?
Yes.
Okay, so that's 2 plus 3 plus 1. That's 6 over 6.
6 and 6. Okay, so
No, that's 1.
okay.
1 ohm. That's correct. So out of this, we can calculate the total resistance. The total resistance is the resistance in series plus the resistance in parallel. Okay, but now we can get R actually. So let's make a question out of that. Very cool. So number 4. What is the reading in R? Sorry, I didn't copy the questions. I just pasted the circuit board, made our own questions. Okay, what is R? Now, the total resistance is the resistance in series plus the resistance in parallel. The total resistance we calculated was 10 ohm. It's 10. The resistance in series is 5. That one on the left-hand side, plus the unknown R. It's also in series. Plus the parallel section we got is 1 ohm. So 10 equals 6 plus R. So R is 4 ohm.
So where did the extra R come from? Because 5 is for the series, 1 is for the parallel, but where did the R come from?
That's a missing resistor value there.
Oh, okay.
You see, yeah.
Yeah.
So that resistor in series there had 2 components, a 5 and an unknown R.
Okay.
Okay, so now there's nothing. Oh, the last one is just what? The last one is just that A2 reading. So now the last question, let's make that one pink. I want to know what A2 is. What is A2? Good. See what you can do. You can put a voltmeter there if you want to. You can put a voltmeter there if you want to. Come, Calvin. Right, help out. Can anyone give me the voltmeter reading over that R resistor?
Will it be?
It's the I
Sure.
times R.
Oh, is it the item?
Yep, it's I times R. V equals I times R. The current there is the total current, which is 2 amps. And the resistor there we've just calculated. What was that? 4 ohm.
Yes.
So that's 8 volts. So I'm losing another 8 volts there. So I've got 20 volts. I'm losing 10 there and I'm losing 8 there. So what's the voltmeter reading over the 3 ohm resistor? Come. I've got 20 Rand starting off. I'm giving 10 Rand, spending 10 Rand, then spending 8 Rand there. How much remains?
2 Rand.
Yeah, 2 volts. So I have a reading there of 2 volts. So the current there is the volts there divided by the resistance. The potential difference is 2 and the resistance is 3. So that's 0.67. So therefore the current is 0.67 amps. The reading of A2 is 0.67 ampere. Quickly, we do another one. Just want to see what we've got here. That one. Oh, you haven't worked with watts yet.
No, sir.
Okay, so we're gonna make this, I don't know, make the questions really kind of basic. Okay. I want to know first, I want to know what's the reading on A1. So the first question is, what is A1? Make a drawing of that, get the calculation or the reading of A1. Then I want to know, can we get A1? No. Yeah, you can. But I would recommend getting the total resistance first. So get the total resistance first, and then you get the reading in A1 for me. They don't ask you to calculate the total resistance. If you can, just do it straight, like it part of your sum.
Okay.
Okay. Saskia, help me out. Help me with the total resistance, please. It is the resistance in series plus the resistance in parallel. Is that correct?
Yes.
That's your equation. Do you have something there? Yes. We have the series bit, which is 2 ohm. We don't have the parallel. Is that correct?
Yes.
Help me out. 1 over R parallel is 1 over 2, 1 over 3 plus 1 over 6, isn't it? Put that in your
Yes.
calculator and flip it around, and you'll get 2 ohm. See if you get it.
Okay, so shall I get a half?
So
then
flip
you
it around.
Will it then be 2 ohm?
Yeah, because you have to flip that fraction around. So that's 2 plus 2. So the total resistance is 4 ohm. And now I can actually work the sum. Now you can work the sum. You can calculate A1. Five minutes left. I want you to calculate A1, V1, and V2.
So my answer is 3.
Okay, let's see. The total current flows through there. So the current is the volts over the resistance. Total potential difference is 12. The total resistance is 4. So the current is 3 amps. That's correct. So therefore, A1 is 3 amps. Good. V1, all the current flows through there. V equals I times R. The current there is 3 amps. The resistance is 2. And that is 6 volts. So I have 6 volts there. V2 is
So
what? Well, I have 12 there. I've lost 6 there. So 6 remains. That is 12 minus 6. And that is 6 volts. Now I want the last thing, number 4. I want to know what is the reading on A2.
So when do we use the formula V equals I times R and V equals I divided by R?
Now you never use V equals I divided by R. It's always I times R.
Volts divided by R.
Oh, when you want I.
Okay, so that's only when you want your
Yeah, look, some students use this triangle. You use it for distance, speed, and time. V,
Oh yeah,
I, R.
okay.
So the volts is I times R. I is V divided by R. And R is V divided by I.
Okay.
Calvin, please get the reading on A2 for me. Help me out. Equation. I equals V divided by R. The potential difference there, we've just done it, is 6. The resistance there is 6. So the reading is 1 amp.
Yes, sir.
Okay, you have to look at this section of the work. You have to complete all the exercises in your textbook. I'll see you next week again. Make sure that you know, somehow found out exactly what you're going to write exam on. Okay, I've got, do I have your exam date?
Yes, our 2 exam dates is